A condition for constructive and destructive interference. Okay, in this video, I will discuss the mathematical approach as to how and what are the conditions that we will get constructive and destructive interference. Okay, so by now we have understood that constructive interference is nothing but when the intensity of light is maximum. Okay, and when will the intensity of light be maximum? The intensity of light is maximum only if the amplitude is maximum, since the intensity is proportional to the square of the amplitude. Got it? So in this video, I will discuss and we will try to find the expression of the amplitude square. Then we will see what will be the condition for which I will be maximum or minimum. Let's say we have the two waves coming from the two coherent sources to be denoted by y1 and y2. And since the two waves are transverse waves, their equation is y1 is equal to a1 sine omega t. So let's say this is the equation of the first wave, and the equation of the second wave, y2, is equal to a2 sine omega t plus phi, where a1 and a2 are the amplitudes of the wave y1 and y2 respectively, and phi here is a constant phase difference between the two waves. By principle of superposition, the resultant wave is y, which is equal to the sum of these two waves, y1 plus y2. Alright, so y1 here is a1 sine omega t from the above equation, and y2 here is a2 sine omega t plus phi. Okay, I think you are familiar with this trigonometric expression sine A plus B. What is sine A plus B? This will be sine A cos B plus sine B cos A. So let us apply this trigonometric equation to this second term out here. So you have a1 sine omega t plus a2 sine omega t cos phi plus a2 sine phi cos omega t. I think this is clear, right? Now what I'm going to do is I'm going to take common sine omega t from the first two terms. So inside bracket I have a1 plus a2 cos phi. Outside of the bracket I will have sine omega t plus a2 sine phi cos omega t. Let's call this sum equation 1. Okay, right. So I'm going to do a little bit of substitution out here. So let us take this part. Let us take this part to be equal to a cos theta, and let this part to be equal to a sine theta. Let us write that down in the next page. Let a1 plus a2 cos phi be equal to a cos theta. Let's call this equation 2. And let's see, what is the second one? a2 sine phi. a2 sine phi, let this be a sine theta. Call this some equation 3. So substituting 2 and 3 in equation 1, or putting 2 and 3 in 1, we get the resultant wave y to be equal to a cos theta sine omega t. A cos theta sine omega t plus a sine theta cos omega t. Let me see if this is, yes, that is correct. Okay, so if I take common again a, then inside of the bracket I will have cos theta sine omega t plus sine theta cos omega t, and that will give me sine omega t plus theta. Okay, call this sum equation 4, which is the resultant wave. The resultant wave having amplitude A. Okay, now how do we find this amplitude A? So that's very simple. We take the two equations 2 and 3, we square and add the two equations 2 and 3, squaring and adding 2 and 3. We get, if you square the equation 2, you get a1 square plus a2 square cos square phi plus 2a1 a2 cos phi on the left hand side. Yes or no? Because this is a plus b whole thing square, right? So I'm just applying that formula. So it is a square plus b square plus 2ab. And on the right hand side, I will simply get a square cos square theta. Similarly, if I square the equation 3, I will get a2 square sine square phi. This will be equal to a square sine square theta. Okay. Now if I add these two equations, what will I get? If I add these two equations, then do you agree or not that, okay, let me do one thing. Let me take like this. Instead of writing that way, I'm going to just add this. Okay, I'm just going to add this here, and I will add this here, sine square theta. I think that is clear, right? So if you look at the left hand side, I have a1 square plus, now from this term and this term, can I take common a2 square? So if I take common a2 square here, what will I get inside of the bracket? I will get cos square phi plus sine square phi plus 2a1 a2 cos phi. Similarly, I will take common here a square. I will get cos square theta plus sine square theta. And you know very well that this term inside the bracket is equal to 1. Similarly, this term inside of the bracket is equal to 1. Okay, so therefore a square will simply be a1 square plus a2 square plus this term. Got it? So let me write that in the next page. So therefore a square is simply a1 square plus a2 square plus 2a1 a2 cos phi. Let's call this some equation. Was it equation 4, the last equation? That is equation 1. Equation 4, so this will be equation 5. Call this some equation 5. Okay, so that is what I told you in the beginning, that we are interested in finding the value of a square. Why? Because once we get a square, then we can find the intensity. Okay, the intensity I this is directly proportional to a square, or we can write I is equal to ka square. So what we are going to do is we are going to multiply k on equation 5 on both sides. So therefore equation 5 becomes k a square k a1 square k a2 square plus 2k a1 a2 cos phi. Got it? So this implies, what is ka square? This is nothing but I. And what is ka a1 square? That is nothing but I1, the intensity due to the first wave. Ka a2 square, that is nothing but I2, the intensity due to the second wave. And here, can I do like this? So we have I1 is equal to ka a1 square, and I2 is equal to ka a2 square, right? So instead of a1, a2, let me write k here. Instead of a1 and a2, from here, what is the value of a1 square? a1 square here will be I1 by k. So this implies a1 to be I1 by k under root. Similarly, from here, a2 will be I2 by k under root. So instead of a1, let me write I1 by k under root, and instead of a2, I2 by k under root cos phi. I think this is clear. So I here will get I1 plus I2 plus 2. Now this k, can I do like this? Can I write it as k I1 I2 under 1 root? This will be k square, right? Root k square, yes or no? Right? So this k, this square and this square root will be cancelled. So I get only k down here. Only k down here. Now this k and this k will be cancelled. So therefore my final equation will become I1 plus I2 plus 2 root I1 I2 cos phi. Okay, call this sum equation 6. This is the expression for the intensity due to the superposition of the two waves. Okay, all right, so now if you look at this equation 6, the total intensity is the sum of the intensities due to the two waves, okay, plus an extra term. This extra term is called the interference term. All right, so let us write it down in the next page. The term 2 root I1 I2 cos phi is called interference term. Okay, so you can see here that the intensity of light, it is a function of cos phi. Okay, and cos phi here, it has maximum and minimum values that we know very well, right? Maximum and minimum values. If you look at the graph of a cos function, let's say this graph, let's say, where is it? This graph here. This is the graph of a cos function, okay? So it has maximum value plus 1 and minimum value minus 1. So where is it maximum? It is maximum when the angle phi is 0. That means it is plus 1 at 0, at 2 pi, at 4 pi, at 6 pi, so on and so forth. So when cos phi is maximum, that is when the intensity will be maximum. Similarly, when cos phi is minimum, that means minus 1, that is when the intensity will be minimum. Okay. Condition for constructive interference. Constructive interference occurs when cos phi, this is equal to plus 1. Okay, so this implies phi will be what? What are the values of phi for which cos phi is plus 1? As you can see here, it is plus 1 where? At 0, at 2 pi, at 4 pi plus 1, at 6 pi plus 1, so on and so forth. So these are actually the even number of pi, even multiple of pi. Yes or no? Even multiple of pi. And how do you write an even number? 2n. That is how you write an even number, right? So this will be 0, 2 pi, 4 pi, 6 pi, etc. So in general, you write 2n pi, where n goes from where? Starting from 0. If you put n to be 0, here you will get 0. 1. If you put n to be 1 here, you'll get 2 pi. 2. If you put n to be 2 here, you get 4 pi. 3. So on and so forth. Okay, so this is the condition for maximum, or sorry, for constructive interference. Let us name this equation as equation 7. Okay, so therefore path difference P is this is equal to lambda by 2 pi of the phase difference phi, right? So you have lambda by 2 pi of phi. Here is this 2n pi, so I can just cancel 2n 2, pi and pi. So I get the path difference P to be n lambda. Call this sum equation 8. So when will you get constructive interference? You will get constructive interference if the if the phase difference between the two waves is an even multiple of pi, or if the path difference between the two waves is a whole number multiple of lambda of the wavelength. Alright, so that is the condition for constructive interference. Let us now look at the condition for destructive interference. Okay, destructive interference occurs when what? Destructive interference means the intensity is minimum. And when will intensity be minimum? If cos phi is equal to -1. Alright, so what are the values of phi for which cos of the angle is -1? Let us look at the graph of the cos function once again. Here, so where is it? -1. -1 are these points. This point, this point, this point, this point are all equal to -1. So it occurs at pi, 3 pi, 5 pi, next will be 7 pi, so on and so forth. So do you agree or not that these are all odd multiples of pi? Yes? So you get here pi, 3 pi, 5 pi, 7 pi, so on and so forth. So therefore phi will be odd multiple 2n plus 1. That is how you write an odd number, yes or no? 2n plus 1 pi. Now what are the values of n? Will n start from 0? Let us see. If you put n to be 0 out here, put n to be 0 here, what will you get? You'll get 2 into 0, which is 0, right? 2 into 0 is which is equal to 0. Actually, this should be minus, not plus 1, okay? That should be minus here. So if you put 2n, if n to be 0 out here, you will get minus pi. Doesn't start from minus pi, it starts from pi, right? So how do you get this first one pi out here? By putting n to be equal to 1. Okay, so if you put n to be 1 out here, you will get 2 into 1, which is 2. 2 minus 1 is 1. 1 into pi, pi. So you're getting the first one. So therefore, the first value of n here is 1, not 0. Right? What is the second value? The second value of n is 2. Now put n to be 2 out here. You get 4 minus 1, which is 3 pi. Put n to be 3. 2 into 3, 6 minus 1, which is 5 pi. 4 pi, so on and so forth. Okay, so this is the condition for destructive interference. What is the, okay, this will be equation 9. So therefore, path difference P, which is lambda by 2 pi into phase difference, lambda by 2 pi, put the phase difference from equation 9, pi, so this pi and this pi will go, so you have P is equal to 2n minus 1 lambda by 2. Okay, let's call this some equation 10. Alright, so what are the conditions for destructive interference? Destructive interference happens, or it occurs, if the phase difference between the two waves is an odd multiple of pi, or if the path difference between the two waves is an odd multiple of lambda by 2. Alright, so these are the conditions for constructive and destructive interference.